Hello, my wonderful Algebra 2 students. We're going to work a few problems from the practice test number 5A. Let us start with the exponent properties on problems 1 and 2. Number 1 is raising several expressions that are multiplied to another power. That will be the multiplying exponents rule. On number 2, you will see that we are dividing some expressions. We are going to change the sign across the line first and then apply either the rule where we add the exponents when we're multiplying or subtract the exponents when we are dividing. We'll see which one we actually need. Let's get started. We're going to raise each one of these things inside the parentheses to the negative 3 power. 5 to the negative 3 times g to the 4 times negative 3 is negative 12 power, times h to the negative 3 to the negative 3. Negative 3 times negative 3, negative times the negative is a positive, is h to the 9th. We now have negative exponents. We can't leave those in our final answer. Change the sign, cross the line. We are going to put h to the 9th on top. It does not have a negative exponent. And on the bottom, we are going to put 5 to the positive 3 and g to the positive 12. We will not leave 5 to the 3rd as that. We will actually compute that value, h to the 9th, over 125 g to the 12th. That's our final answer. Now on to number 2. Before we go ahead and do any work, let us change the sign and cross the line. We're going to take the a to the negative 3 down to the denominator as a to the positive 3. That b to the negative 5 will come up on top as a b to the positive 5. Let's write. B to the 5th, b to the 9th, over 21 a squared a to the positive 3. We now have expressions both on the top and the bottom which require us to add exponents. We reduce the 12 over 21, divide top and bottom by 3, not 4. 4 is left on top, 7 is left on bottom. b to the 5th times b to the 9th, 5 plus 9 is 14. We have b to the 14th on top. A squared times a cubed, 2 plus 3 is 5. We have a to the 5th on bottom. That's our final answer. Let us move on to scientific notation problems. For the scientific notation problems, we will separate. We will multiply the numbers and then multiply the powers of 10. On number 4, we will divide the numbers and then we will divide the powers of 10 separately. So, for the first problem, 6.1 times 3.3 separately, put that in parentheses, times the powers of 10. 10 to the 8th times 10 to the negative 2. 6.1 times 3.3 is 220.13. 10 to the 8th times 10 to the negative 2, add the exponents. 8 plus negative 2 is 6. That's 10 to the 6th. This is not in proper scientific notation. We need to move the decimal point one place to the left so that this number is between 1 and 10. 2.013. Since we divided that number by 10, we must multiply the power of 10 by 10, thus increasing the exponent. Move the decimal point to the left, increase the exponent. This is 10 to the positive 7. That's our final answer for number 4. we divide 3.5 by 7.0 times 10 to the negative 3 divided by 10 to the negative 9. 3.5 divided by 7.0 is 0.5. 10 to the negative 3 divided by 10 to the negative 9. We subtract the exponents. Negative 3 minus negative 9, that's a double negative. So it's negative 3 plus 9 is positive 6. Again, this is not in proper scientific notation. We must move the decimal point one place to the right, giving us 5.0 times 10 to the, since we move the decimal point one place to the right, we must reduce our exponent by 1, thus giving us 10 to the 5th. 5.0 times 10 to the 5th, this is our final answer. On problems 5 and 6, we are asked to tell whether the expression is a polynomial or not. That means that we must have no fractional exponents. So on number 6, this is definitely not a polynomial, because it has an exponent of 1/2. However, number 5 is, but it is not in proper form. We need to go descending degrees, so we will list 8x to the 4th first, 9x cubed second, 10x squared third, and then the minus 3. There is no linear term, so we will not write one. That is in standard form of a polynomial. Naming it by degree and number of terms, we have a quartic, 4-term polynomial. Okay, let us move down and do synthetic substitution. Okay, for synthetic substitution, we are ultimately plugging it in. So we want to find out what f of 4 is. On the first one, we want to find out what g of negative 2 is. So we put the value that we want to plug in the bracket on the left-hand side. We then list out our coefficients, making sure that we put in zeros for any terms that are not there. Remember, we must have one of each term. Since number 7 is a quartic, we must have a quartic, a cubic, a quadratic, a linear, and a constant term. Any that are missing will give us a 0 in its place. Leave a space, draw the line, drop the first term, and then of course we're up to our series of multiplying and adding. 4 times 3 is 12. Added to negative 5 is 7. 4 times 7 is 28. Added to negative 2 is 26. 4 times 26 is 104. Added to 6 is 110. 4 times 110 is 440. Leaving us with 441 in our final spot. Put this in proper form. F of 4 is equal to 441. Moving to the second problem. Negative 2 we are plugging in. Write down the coefficients. 7, 8, 0, 0, 12, and negative 3. We put in 2 zeros because we have no cubic and no quadratic terms. Drop the 7. Negative 2 times 7 is negative 14. Add 8 and negative 14 is negative 6. Multiply negative 2 times negative 6. Negative times negative is a positive. 12. 0 and 12 is 12. Negative 2 times 12 gives us negative 24. 0 and negative 24 is negative 24. Multiply. Negative 2 times negative 24. Negative times negative is a positive. 48. 12 and 48 is 60. Negative 2 times 60 is negative 120. Negative 3 and negative 120 is negative 123. In proper form, g of negative 2 is equal to negative 123. And we have our answers.